Today we're going to be talking about pH. pH is a measure of the concentration of hydrogen ions in a solution. Essentially, it measures how basic or acidic a solution is on a scale from 0 to 14. If a pH is 0 to 6, it indicates a high concentration of hydrogen ions, meaning that the solution is acidic, while a pH of 8 to 14 indicates a low concentration of hydrogen ions, meaning that it is a basic solution, while a pH of 7 indicates that the solution is neutral and that the hydrogen and hydroxide concentrations are equal. To calculate pH, we would use the equation pH equals the negative log of the hydrogen concentration. For example, if we are given that the hydrogen concentration is 5.4 times 10 to the negative fifth, we would plug that into the equation, so the pH would be negative log of 5.4 times 10 to the negative fifth. When we put that into the calculator, we do negative log of 5.4, and when putting it into the calculator, we do not multiply it by 10 to the negative fifth, but we do second, comma, to get the e to the negative fifth. So we would find out that the pH is 4.2676. But we also have to consider significant figures, and because the concentration only has 2, the final answer must have 2. And with pH, the significant figures are counted after the decimal, so the final answer would be 4.27. We can also use the pH and work backwards and calculate the hydrogen concentration. For that, we would use the equation hydrogen concentration equals 10 to the negative pH, which is the negative antilog of the pH. So that if we use the answer we got in the first example, 4.27, we can plug that into the equation, so the hydrogen concentration is equal to 10 to the negative 4.27. When we put that into the calculator, we would do second log to get 10 to the negative 4.27. So in that, we would figure out that the hydrogen concentration is 5.3703 times 10 to the negative fifth molar. But again, we would have to consider significant figures. Because the pH has 2, the final answer would also have 2. So the hydrogen concentrations would be 5.4 times 10 to the negative fifth molar, which, as you remember from the first example, was what the concentration was. So you could either work forward or backwards.